In this chapter, we will study OS 400 commands and also see how to create our own commands. Commands have many advantages over application programs. A command can call an application program, thus eliminating the need for the call command. A user can be prompted for command parameters, whereas he will have to remember and supply the right parameters when calling applications. You can set default values for command parameters that will be passed on to the application program. One single command can be written that will run a series of commands that are used frequently. An OS 400 command is made up of two objects: a command definition that describes the command along with the parameters and their attributes. The second part is the command processing program that performs the actual operations required by the command. Let us look at the command definition first. Suppose we have a program to print invoices that accepts three parameters: an invoice number, the number of copies to print, and the number of invoices to be printed per page. A user can call the application along with the required parameters. Alternatively, we can create a command definition so that a user could be prompted for the parameters. The command definition source contains a number of statements. The command statement is used to specify a prompt for the command. This statement is required in any command definition source. There has to be one parameter statement for each parameter that is required by the program. We shall examine each of these statements later. When the user executes the command, he will be prompted for the parameters, as you can see here. To create a command definition, we first code the description in a source file. The source file for command definitions is called QCMDSRC. We use create command to compile the description. Here we specify the following parameters: the name to be given to the command object, the name of the source file and source member, the name of the command processing program that is to be called. The object created is of the type *CMD. The command processing program should exist before the CHGCMD command is used. The program can be written in C, RPG, COBOL, or any other language on the AS400. The program is written to receive the required parameters just like any other program. Let us see how the command is processed. To run the command, we simply type in the name of the command from any command line and press the F4 function key to be prompted for parameters. The parameters are then passed to a command analyzer that checks for the validity of the parameters. If the parameters are found to be valid, the command processing program is started and the parameters are passed to it. If the parameters are not valid, an error message is returned to the user. Let us look at the example we saw earlier. This command is used to call a program that prints invoices. The first statement in the source, that is, the command statement, is required in all command definitions. The remaining statements are optional. The command statement is used to describe the prompt text that is to be used as a heading for the command on the prompt display. Each of the parameters requires one parameter statement. The first parameter statement is used to prompt for the invoice number. The other two statements prompt for the number of copies to be printed and the number of invoices to print per page. The keyword parameter identifies the keywords that will appear. The keyword for the first parameter is INVNO. The other keywords are copies and number. Normally, a user is shown the choices for a particular parameter. However, the keywords will be displayed on pressing the F11 key, which is a toggle key that is used to switch between choices and keywords. The type and length parameters identify the data type and length of the respective parameters. The minimum parameter is used to specify that this is a required parameter. The user has to enter a value for this parameter. The default parameter is used to specify a default value for a parameter that will be displayed on the screen. This parameter cannot be specified when the minimum parameter is specified. Restricted parameter with a value of *yes is used to restrict the valid values for the parameter to the set of values identified by the values, special value, or single value keywords. The values parameter identifies a set of valid values that are allowed for this parameter. Sometimes we might want to allow the user to enter values in more than one form, such as allowing a value of 1 to be entered either in numeric form or in character form, that is, as ONE. We have the parameter copies that takes character values. Using special value, we specify that the allowed values for this parameter are 1, 2, 3. Alternatively, the user can also enter these values in the numeric form. The numeric forms will automatically be converted to the corresponding character values specified, such as 1 will be converted to ONE. We can also use it to bypass some name verification logic when entering parameters. For example, a parameter that has a data type *name requires that the values for this parameter follows the valid naming requirements for object names. We can use special value to specify that *libl is also a valid value for this parameter, even though it does not conform to the normal naming conventions. There are 6 different statements that can be used in command definitions. They are command, parameter, qualifier, element, dependencies, prompt control. Let us look at each of these. We have seen the command and parameter statements earlier. The element, qualifier, dependencies, and prompt control statements are used to further describe a parameter that has been defined with the parameter statement. Let us look at the command statement once more. The command statement is used to describe the prompt text that is to be used as a heading for the command on the prompt display. It is a required statement in all command definitions. First, let us look at the parameter statement. We saw some of the parameters that can be specified for this statement, such as keyword, type, length, minimum, restricted, values, special values, default, and prompt. In addition, you can also specify the following parameters: full, maximum, relation, range, prompt control, and choice. The full parameter is used to specify that the number of characters entered for the parameter must be exactly the same as that specified in the length parameter. For example, you might want the user to always specify the invoice number using all the 6 characters. The maximum parameter is used to define the number of values that can be specified for a parameter that can take on multiple values. For example, on the display object description command, the type parameter can take on multiple values. The relation parameter can be used to specify a relation between this parameter and a constant or another parameter. For example, we can say that the number of copies parameter should have a value less than 10. Similarly, the range parameter is used to specify a range of allowed values. We can, for example, say that the number of values parameter can have a value between 1 and 10. The prompt control parameter is used to control when the user will be prompted for the parameter being defined. We can specify a value of *PMT_RQS to specify that the parameter will be prompted for only when the user presses the F10 key to request for additional parameters. Or we can also specify that this parameter is dependent on another parameter with the dependency being defined at the statement label defined on the prompt control parameter. The choice parameter is used to define the set of choices that is to be displayed on the prompt screen for this parameter. Let us look at the qualifier statement. This is used to define a qualified name as a parameter. On the parameter statement, we specify a label name for the type field. The label identifies two qualifier statements that define the two parts of the qualifier name. On the qualifier statement, we can use the same parameters as those used on parameter statements. The qualifier statement for the object name is specified first. The prompt text for the object name has to be specified on the parameter statement itself and is not allowed on the qualifier statement. The qualifier statement for the object has to be followed by the qualifier statement for the library. A parameter of the type *name has a default length of 10 parameters. A qualified name is passed to the command processing program as one single field with the object name in the first 10 bytes and the library name in the next 10 bytes. The command processing program should be coded to separate out the two parts of the qualified name before using it. As we saw earlier, sometimes a parameter can take on multiple values, in which case we use the maximum parameter to specify the maximum number of elements allowed in the list. This type of list, where all the entries are of the same type, is called a simple list. A list could also comprise elements of different types, as is the case with the log parameter on the change job description command. To define a mixed list, we specify a label name in the type parameter. On the statement referred to by the label, we define each element of the list using the element statement. The dependencies statement is used to define dependencies between parameters. For example, we can say that if a value *out file is specified for the output parameter, then a value has to be specified for the out file parameter. The prompt control statement is used for prompt control and identifies the conditions under which the parameter will be displayed on the prompt screen. For example, here the out file and out member parameter will be prompted for only if the output parameter has a value of *out file. With this, we have looked at most of the features available for creating CL commands. Before we end this chapter, let us look at the change command and change command default commands that allow us to modify existing commands. With change command, we can modify the attributes we had specified when creating the command object using the CHGCMD command. The change command default command allows us to change the parameter default values without having to recreate the command. Summary. This brings us to the end of this topic. Let us take a quick look at what we have covered here. In this chapter, we looked at the OS 400 commands. We saw how to define and create user-defined commands that work like the OS 400 commands. We saw the two parts of a command, that is, the command definition object and the command processing program. We saw how to code the command definition object. We saw the CHGCMD command that is used to create command definitions. We also saw how the command processing program can be written to receive the required parameters.